In this video, we're going to go through an example of solving a buffer problem using the Henderson-Hasselbalch equation. So to start off this problem that we have here, we have a buffer that's formed when 150 mils of a 0.025 mole per liter solution of ethanoic acid is added to 22.9 mils of a 0.05 moles per liter sodium ethanoate. And we want to calculate the pH of this buffer solution given the Ka of ethanoic acid. So let's start out kind of picking out some of the information we have. We have a weak acid here, and we have its concentration and the volume that we've used of it. And then maybe let's pull this out in a different color. We have a salt of our weak acid, and we have its concentration and its volume that we're using. And then finally, the other piece of information we have is a Ka value. So when we're looking at this, we need to recognize weak acid, salt of a weak acid. So this is going to be an acidic buffer, and we're going to use the equation pH is equal to pKa plus the log of the salt concentration divided by the acid concentration. So it's pretty easy to come up with a pKa because we have a Ka value here. And that's nice and easy to come up with. What's tricky about these questions is coming up with the salt concentration and the acid concentration. Now, in this particular problem, what we have is we're taking our acid and we're adding it to a solution of our salt. And so effectively, we're diluting both of those solutions. So let's kind of take a look at the acid first. So the acid, we have a 0.025 moles per liter solution, and we're going to take 150 mils of that. So we can use the concentration times volume equation to determine how many moles of that we're using. So we got 0.025 times, we got to change that 150 mils into liters. And then effectively what we're doing is we're taking this 22.9 mils and 150 mils and creating a new solution. So if this is our moles here, then to get our new concentration, we have to divide it by our new volume. And so our new volume is 150 mils or 0.15 liters plus the 22.9 mils or 0.0229 liters. I'm just going to leave it this way for a sec because I want to now take a look at the salt concentration in the same way. For this one, we have 0.05 moles per liter, so we're going to put that in here. We're going to take our volume of our salt, so 0.0229. And then again, this is our moles, and then we want our total volume here, so it's going to be the 0.15 plus the 0.0229. Now, what we can recognize here, we could do these calculations and that's all fine and dandy, but we have a common denominator in both. So if we're sticking these equations up into this equation, these two effectively cancel each other out. So really we can put the moles in here because the total volume is the same for both, and it will end up giving us the same value here. So knowing that then, we can go ahead and use our equation here. pH is equal to pKa, so that's going to be the negative log of our Ka value, and plus the log of the salt. So if we take 0.05 times 0.0229, we get 0.001145. And then for our acid, if we take the 0.025 times the 0.15, we get 0.00375. Okay. And if we did this calculation then, we get about 4.7447 and so on. And then our second piece is 0.5152-ish. And then doing our calculation here, we end up with a pH of 4.23. So this buffer solution would have a pH of 4.23. So I think really what we need to understand here is our equation, and the big things is coming up with the concentration of our salt and the concentration of our acid. Once you have that, using the Henderson-Hasselbalch equation is relatively easy. Okay, so that's it then for this video. We'll see you in the next one.